Welcome to another BacDive video tutorial. Today I want to explain how you can access the API using the BacDive R package. I will first talk a bit about the installation of the package and the initialization of the BacDive client, and then explain the three main functions of the package: fetch, request, and retrieve. The R package is available in the RForge repository and can be installed within an R session using the install packages function. Once the package is installed, you can load it using the library functions. Then you use the open BacDive function with your login credentials to initialize the BacDive client. I have this R console here to show you how to use the BacDive R functions, and as I have already installed the BacDive package, I'm just going to load the library now and initialize the BacDive client with my email and password. The R package contains three functions for API requests: fetch, request, and retrieve, and the first one, fetch, simply implements a request to the fetch endpoint of the API. So what that means is that we can make a request with BacDive IDs and receive detailed information on the strains we searched for. In my console here, I'm going to now use the fetch function with one BacDive ID, and the output looks pretty similar to the raw JSON output of the API, which we saw in the browser in the previous video if you watched that, the API introduction video. Again, the actual data is in the results field. And as you can see, we have here all the information on the strain that you could also see on the BacDive website if you would search for the strain there. I can also use the fetch function with several BacDive IDs at the same time. Here I'm doing an example with two BacDive IDs, and as you can imagine, the output of this would actually be quite long and it would be hard to find what you're looking for. But it is possible to transform the output into a data frame, which makes the data easier to handle. And you can do this using the sDataFrame function. The main strain data categories are now the different columns of the data frame, and the two strains are represented by two different rows. The request function implements requests to the other four endpoints of the BacDive API, to which we can make requests using identifiers like culture collection numbers, taxon names, and sequence accession numbers, and receive back the respective BacDive IDs. Using the request function with a culture collection number works like this. We give here our culture collection number as the query of the request function, and for the search parameter we put in deposit, which means that we are searching with the culture collection number. The BacDive ID we receive is of course again in the results field. The same also works with a sequence accession number. Here the nucleotide accession of a 16S rRNA gene, and the search parameter in this case is simply 16S. And we again receive the BacDive ID here in the results field. When I make a request with taxon name, like the species name Myroides odoratus, I can of course receive several BacDive IDs. In this case, the count field tells me that there are 19 strains for this species in the BacDive database, and in the results field I can see all of these 19 BacDive IDs. But when I do the same for the genus Myroides, I run into the major drawback of the request function. As you can see here, there are 106 strains of the genus Myroides in the BacDive database, but in the results field I can only see 100 BacDive IDs. As I explained in the API introduction video, when we get results back for more than 100 strains at a time, we have a pagination on our API, and this request function can't deal with that. It only gives out the results from the first page. So what the request function is useful for are cases in which you want to have only BacDive IDs and no further details on the strains, and in which you know that your search won't give out more than 100 IDs for one request. In most other cases, it makes more sense to use the retrieve function. This function can retrieve data directly using non-BacDive IDs and taxon names, and it also does handle more than 100 strains. As a minor drawback, it is slower than the request function and has to download more data. But if you need the detailed information, this is the function to use. I now use retrieve to again search for all strains of the genus Myroides that are present in BacDive, and again I am shown that there are 106. And I now can transform the received data into a data frame, as I did with the output of fetch earlier. And this data frame has 106 rows. So I now really have information on all the 106 strains in my data frame. Now you can look through this data frame to find the specific information that you need. Let's say I want to know, for example, how many of these 106 strains of the genus Myroides are type strains. To find out, I iterate through all the strains, so through all the rows of my data frame, and go into the type strain field. To find out where exactly the field is that holds the specific data you want to look at, you will probably have to have a closer look at the data frame first and maybe do a bit of testing. I have already found where exactly the type strain field is, so I simply go through every row and ask, does the type strain field say yes? And if it does, I add a 1 to my numerator. And I count that 17 of the genus Myroides strains in the BacDive database are type strains. In my second example, I want to go through a number of DSM numbers, in this case DSM 1 to DSM 20, and find out if these DSM strains are present in the BacDive database, and if they are, I want to know their BacDive IDs. I first initialize an output data frame with 2 columns and 20 rows, and name the columns DSM number and BacDive ID. Then I go through the numbers 1 to 20 and add the prefix DSM to each number so that it becomes a DSM identifier. I then already saved this number in my output data frame before I sent an API request to the BacDive API using the request function with that DSM number. If the strain is present in the BacDive database, the count field of the output says 1. So then I save the BacDive ID I received back in the BacDive ID field of my data frame, or if the count field is not 1, it's 0, then I simply put an NA into this field. In the end, I print out this data frame I produced, and it looks like this. So this is it for the BacDive R package. You have learned how to install it, how to initialize the BacDive client, and how to use the API request functions. If you have not yet watched our API introduction video, I want to recommend it to you. And if you'd rather use Python than R, you can watch our API Python package video tutorial. See you then. Bye.